Good morning, students. Today we are going to read bond breaking and bond forming energies in the topic of energy change of chemistry O levels. This is somewhat technical topic, so concentrate yourself. The topic is bond breaking and bond forming energies. Bond breaking and bond forming occur during a chemical reaction. It is the breaking and making of bonds that cause energy changes in chemical reactions. Breaking a bond is endothermic, that is, energy is needed to break a bond. For example, the breaking of H2 into H plus H is an endothermic reaction. Delta H is positive 436 kilojoule per mole. 436 kilojoule per mole is required to break 1 mole of covalent bonds in the hydrogen molecules. On the other hand, forming a bond is exothermic. That is, energy is released when a chemical bond is formed. The reverse of the previous example is when H plus H is combined to form a bond of H2. Minus 436 kilojoule per mole energy is will be given out to the environment. 436 kilojoule is released to form 1 mole of the covalent bonds in the hydrogen molecules. The bond energy indicates the amount of the energy needed to break a covalent bond, and it is also equal to the energy released when the same bond is formed. So it means when H2 molecule is braked to form H plus H, plus 436 kilojoule per mole energy is required. And very reverse process, when H plus H is combined to form H2, minus 436 kilojoule per mole energy will be released to the environment. So the bond energy indicates the amount of the energy needed to break a covalent bond, and it is also equal to the energy released when the same bond is formed. Example is bond energy of H2 bond is 436 kilojoule per mole. 436 kilojoule is needed to break 1 mole of H2 bonds. 436 kilojoule is released when 1 mole of H2 bonds are formed. Now the very important point is, the stronger the bond to be broken, the more energy is taken in. A triple bond requires the most energy to break, whereas a single bond is easiest to break. Examples are here. 347 kilojoule is needed to break 1 mole of carbon-carbon single bond. But when carbon-carbon double bond is there, 612 kilojoule is needed to break 1 mole of the carbon-carbon double bond. And even more tough when carbon-carbon triple bond is there. 838 kilojoule is needed to break 1 mole of the carbon-carbon triple bond. So it means the stronger the bond to be broken, the more energy is taken in. A triple bond is the most tough to break as compared to the double and single bond. So it means single bond is the easiest to break. The bond energy measures the strength of a covalent bond. More the energy required, more stronger will be the bond. And students, there comes frequently a question that is required to find the bond energy, and in that kind of question bond energies will be given in the question. So here are some bond energies which are generally used in the chemistry questions. During a chemical reaction, ER, total energy required to break bonds in the reactants. EP, total energy released when new bonds are formed in the products. If energy required is greater than the energy released, it will be endothermic reaction. If energy required is lesser than the energy released, it will be exothermic reaction. Because in exothermic reaction, heat energy is released to the environment, whereas in endothermic reactions, heat energy is taken in from the environment. The heat change of a reaction can be found using the formula below. Chemical reaction needs an input of the energy to start them. The reactants will not be converted into the product until an energy barrier has been overcome. Heat of the reaction. Total heat energy absorbed when cold bonds are broken in the reactants minus total heat energy released when new bonds are formed in the products. So in short form, total heat energy absorbed minus total heat energy released is the formula of the heat of reaction. The following examples show how heat of the reaction can be calculated from bond energies. And here is a question. Formation of the hydrogen fluoride from its elements. Here is the equation. H2 plus F2 forms 2HF. Use bond energies to calculate delta H for the reaction. From the reaction you can clearly see one HH molecule is there, one FF molecule is there, and two HF molecule is there. So we required the bond energy of HH, FF, and HF. So we are going to note the energies. Here is the HH energy, that is 436. Here is the FF energy, that is 158, and here is the HF energy, that is 568. And in the equation there is one molecule of the HH, one molecule of FF, and two molecules of HF. So this energy will be multiplied with 2. So look now. Breaking bonds in the reactant molecules. So one HH bond will be broken, one FF bond will be broken. So heat energy required is bond energy of the HH bond plus bond energy of the FF bond. These are the bond breaking energies that are required. So 436 plus 158, we will solve it on the calculator. That will give answer 594 kilojoule. And now bond forming energies are required. So two molecules of the HF energy was 568. So forming bond in the product molecule, two HF bonds. So 2 into energy of HF, so 2 into 568. Solving it on the calculator, 1136 will be the answer. And finally, bond breaking energies minus bond forming energies will be the formula of delta H. So 594 minus 1136, that will give the answer of minus 542 kilojoule. Minus sign shows it is an exothermic reaction because as a resultant, the energy will be given out to the environment. Another question is here. Decomposition of the ammonia. From the equation we can clearly see 2NH3 forms N2 plus 3H2. Use bond energies to calculate delta H for the reaction. Breaking bonds in the reactant molecule. So whenever this type of the value comes, you have to multiply 2 with the bottom value. So 2 3s are 6. So 6 bond energy of NH is the breaking bond in the reactant molecule. So there are actually 6 NH bonds. The method is multiply the coefficient with the bottom value. 2 3s are 6. So 6 NH bonds are there. 6 NH. Now we want the value of NH. We will go into the table. So NH is here, that is 388. So we will put 388 into the bracket, that will be multiplied by 6. Solving it on the calculator will give us the answer. So this is the breaking bond energy. On the right side we have 1 NN and 3 HH bonds. So now we want NN bond energy and HH bond energy. Look now, 1 NN bond and 3 HH bonds are there. So bond forming energies are bond energy of NN plus 3 into bond energy of HH. So we will go to the table again and we'll note the values. Here is HH, that is 436, and here is NN, that is 945. Now we will put these values into the equation. So 945 was the energy of the NN and 436 was the energy of HH. So we have placed 436 into the bracket, that will be multiplied by 3. Solving it on the calculator, we will get the answer 2253 kilojoule. Finally, the resultant energy will be find it out by breaking bond energy minus forming bond energy. It means 2328 minus 2253 will be the answer. So 2328 minus 2253, solving it on the calculator will give us this answer. Because the answer is in positive, so it will be endothermic reaction. So it means this reaction is endothermic, that will take heat from the environment. And other question is here. Use bond energies to calculate delta H for the reaction. So here is another method to solve the question. Here is the molecular formula. First write the molecular formula into structural formula. You can solve this question by the same previous method as well. That is easy method. And here I'm telling you another method that is also a correct method. So it will be up to you which method you will use. So first convert the molecular formula into structural formula. So CH4 can be written like this. From here we can see 4 CH bonds are there. 2 OO bonds are there. 2 CO bonds are there and 2 OH bonds are there. Next list is the bonds that are broken. So 4 CH bonds energy is required, 2 OO bonds energy is required. That can be seen from here. So now we are going to the table to find the value of CH and OO. So here is CH, that is 412, and here is OO, that is 496. So these values are going to be placed in the equation. So look here, 4 into CH value was 412. Solving it on the calculator will give us 1648 kilojoule per mole. And OO energy was in the table, that was 496. So 496 will be placed into bracket. So 2 into 496 will give us 992. Now adding these two values will give us the total bond breaking energy, that is 2640 kilojoule per mole. On the right side, we have 2 CO bonds are there and 2 OH bonds are there. So we want CO and OH bond energies. So this is CO bond energy and here is OH bond energy. So CO and OH bond energies will be taken from here to put in the equation. So CO bond energy and HO bond energy from the table will be put into the bracket now. So CO bond energy is 743, that will be multiplied by 2. Solving it on the calculator will give us answer 1486 kilojoule per mole. And HO bond energy was in the table, that was 463, so that will be placed in the bracket. That will be multiplied by 2. Solving it on the calculator will give us answer 926. Now adding these two values will give us the bond making, bond forming energy. So that will be 2412 kilojoule per mole. So this is total bond forming energy and this is total bond breaking energy. And finally the heat of the reaction is, formula is energy required to break bonds minus energy given out when bonds are made. So bond breaking energy is 2640 minus bond forming energy is 2412. Solving it on the calculator will give us answer 228 because the answer is positive. So this is endothermic reaction because heat is taken in from the environment. Here is another question. The equation below shows the reaction between nitrogen and oxygen, and the reaction is N2 plus 2O2. 66 kilojoule energy is also there, forms 2NO2 equals. A part is this an exothermic or endothermic reaction? Explain your answer. So the answer is endothermic reaction because 66 kilojoule of the heat energy is absorbed in this reaction, and this is clear from the equation. B part, draw an energy diagram to represent energy changes for this reaction. So because this is an endothermic reaction, so reactants, products will be put above, reactants will be put down. Delta H will carry the sign of upward, and delta H in this question is plus 66 kilojoule. So we will put plus 66 kilojoule equal to delta H, and here is the energy, that will always have upward arrow, energy written will be on it. The C part is how much is the energy change for the formation of the 0.1 moles of the nitrogen dioxide. So here is nitrogen dioxide. This is clearly seen from the equation that 66 kilojoule energy is required to make 2 moles of the nitrogen dioxide. So formation of 2 moles of NO2 requires 66 kilojoule, and from here formation of 0.1 moles of NO2 requires 66 over 2 multiplied by 0.1. Solving it on the calculator will give us this answer. So this energy is required to make 0.1 moles of NO2 molecules. Here are some more questions. Dissolving ammonium nitrate in water is endothermic. Which graph shows how the temperature alters as the ammonium nitrate is added to water and then the solution is left to stand? The answer will be B. And the explanation is heat energy from the water is absorbed to break the bonds between ammonium ion and nitrate ion and form mobile ions in the solution. And after all the ammonium nitrate is dissolved, the temperature returns to the normal like this. First, the temperature will fall because the heat is taken in from the environment, and then after completion of the reaction, the temperature will go back to the normal. Exam tip for you is dissolution is a bond breaking process, hence endothermic. Another question is here. In which equation is the sign of the energy change delta H correctly shown? So the answer is A part, because A is bond breaking reaction, so it will have a positive sign because it is an endothermic reaction. B part is also endothermic because this is also a bond breaking reaction. It should have a positive sign, but here is a wrong sign given. So this will be discarded. This is a exothermic reaction. It will have positive sign, but negative sign is given, that is wrong. It will also be discarded. This is also a exothermic reaction, but it is wrong sign given. It should have negative sign. So it is also discarded. So B and C are also bond breaking. These are bond breaking reactions. They should have positive signs, but wrong signs are given, and hence have positive enthalpy change. D is combustion exothermic reaction, has negative enthalpy change. So A is the right option. So students, this was the lecture on breaking and bond forming energies. This is very important question. This is very important lecture because a question from this portion always come in the paper. So practice a lot at home by writing it again and again. Good luck students. Read this lecture again and make your notes. Thank you so much.